Hey guys, what's up? Welcome to this week's video. In this week's video we're going to do something completely different to the usual. We're not going to make a shooting game or a third person game or anything like that. Now this is a very old game that I've got on the screen here. It's called Tux Typing, and essentially what it is words will drop from the top of the screen and you'll have to type them out before they reach the bottom, or you'll lose points, and you'll lose the game. Obviously, if you type the word out before it reaches the bottom, you get points, and then you can score, and then you can win. Now, I want to make a very simple version of this. Maybe instead of words, we'll just have letters. And depending on how long this takes to record, depends on whether I have time to add difficulties to it and stuff like that. But the idea would be letters would drop from the top of the screen, and the more points that you get, it would slowly increase your difficulty, which means that the letters would drop quicker and quicker. So then you can sort of try and achieve a high score before you let all the letters drop out the bottom and you lose the game. That being said, you're probably going to need a character set. Now, we're going to use a 2D side-scrolling template. Now, by default, this is a really good one to use. Now, unfortunately, Unreal 5 doesn't come with a 2D side-scrolling template. So doing this in Unreal, just from a template point of view, will be a bit harder. But yeah, like I said, obviously I'm going to have letters falling from the screen. So you're going to need sort of a sprite sheet with letters. If you type in PSX alphabet sprite, you'll get this one. You can right click and just save it, and then we can run with that. I've already got that, so what I'm probably going to do is just import that now. So import into game. I've saved that on my desktop, and there it is. Okay, so once you've imported that, what you can do is you can right click, and there's a sprite action, and you can create sprites or extract sprites. I think might be the better one to do. And you can see here with the auto mode, it's actually really clever. It's already selected each of the letters which we're going to expect, and the sprite naming template here on the side, I'm just going to put letter, and then what's the little cryptic code? Is it 0 like that? Letter 0. So indexing starts at 0, and that should be it. So if we hit extract now, okay, so the naming hasn't worked quite as expected, but either way, it's all there. So I can see my entire alphabet and numbers are here. I'm not actually going to use any of the sort of special items at the end. I just want the alphabet. They all seem to look fine, so that's pretty good. That's a good start. However, I am going to create a new folder called sprites, and get all of them in there. Move, and I guess we can keep that one there. So just to start out, if we press play, let's just see what happens. So at the moment we've got a player character which obviously moves around, and the camera just follows the player. So if we zoom out, we see we get this little structure. Now, I don't want any of these assets here in the world. There's a little box collision, don't want that. It's fine. And technically, I don't even want the 2D side-scrolling character. So we can delete that. I don't need a player start. So yeah, that'll just spawn in anywhere. So I think the first things first, we're going to try and get a camera in here. So what I'm actually going to do is, I'm in the blueprint, I'm going to go to the game mode. I'm going to have a look here and see if I can select none for player. So there we go, we just get a blank camera in the middle of nowhere. But that's not necessarily what I want. I want maybe a camera to be here like this. So to do that, what I'm going to do is on the left here, I'm going to go to all classes, and you can even either scroll down to camera, or you could just search at the top for camera. I'm going to right click on the camera and I'm going to pile up, and then what that allows me to do is that allows me to fly my camera over to a position where I'm happy with. So I don't want to see these like sort of pyramid things at the bottom. So I guess that will be about good. Now what I am going to do while I'm still piloting it is I'm actually going to set the X to 0 and see where that puts me. And I'm going to set the rotation to 0, and I'm going to set that to -90 and set the X rotation to 0. That's put me in a sort of funny position here. So there's probably a good chance that this background and stuff isn't central, which I can see it's not. I'm going to get rid of that template text in the middle. And then where's my camera gone? Camera actor. Tell you what, let's delete these folders too. So I'm going to keep the background, the left edge and the right edge. Now I'm going to just eject from the camera by pressing this little eject button. I'm just going to fly out a little bit. Now what I am going to do is I'm going to try and straighten up these borders here. So I'm going to change that to 2500. I'm going to change this left one to -2500, which brings that in nicely. And then what I can do is now I can put my camera. See, if you look at the camera now, it's actually more central. So if I right click again and pilot, I'll see what the camera sees. Now what I can do is I can move myself back or forward. Probably forward. Forward's probably a better. So there we go. So now I'm just going to tidy up the X again. This is 1750. That's probably a good little bit to do. Now that gives me a nice little border on the edge here and here. The height, I like the height actually because there's just enough darkness at the top and there's just enough lightness at the bottom. But that being said, I might actually go up a little bit more. So yeah, I've gone up to 1750 and that looks about nice. So if I now eject from that camera, but with the camera still selected, on the right we'll see auto player activation. We want to set that to player 0. Then if we press play, when we play the game now, we get this nice background, this nice template, and we can have the letters start dropping in from above. We're going to need to sort of randomly generate a letter. Now, there's a couple of elements to this. So what we're going to do is create a blueprint class. It's going to be an actor, and I'm going to call this one letter generator, or letter gen will probably be a good abbreviation. And I'm going to open that up. So typically that's opened up on the other screen. So with this blank actor, what we need to do is we need to be able to display one of those sprites. So we need, I think if I remember, it's going to be a paper sprite. So we'll do, I'll just type in sprite. Let's just see what comes up. So we've got paper group sprite and paper sprite. So it's a paper sprite. And with that selected, on the right hand side for source sprites, if I just go down to the PSX alphabet 0, we can see that that's now displaying the character A. Now the thing is, we're going to need to make all the letters available, and then we just need it to pick one at random. So we can't just make 26 of these and have it pick 26 different actors. Instead, what we can do is on the right hand side under variables, we can create a new variable and just put available sprites. And instead of it being a boolean, we can have this as a paper sprite. And then what you can do, you can right click on the icon, so it goes from this sort of spade icon to sort of the block. It's the array icon. Now if you hit compile, on the right hand side now with this variable selected, you'll see that you can add array elements. Now we're going to need to add 26 if it allows me. There we go. For some reason it keeps freezing up. Okay, so I've got 25, I need 26. Now, this bit's going to be a little bit tedious, so I'll probably cut to the end of this bit, but essentially what we need to do is our 0 is going to need to be A, and then, as you've probably assumed, we're going to need to go through each one of these now, doing the entire alphabet. So I'll probably cut straight to the end now. Okay, so I've just finished doing all of them. So we've got the entire alphabet here numbered from 0 to 25. Now in the event graph, what we can do is, because we are going to be spawning this sprite, we can just use the event begin play, and then what we can say is, here's the available sprites that you can pick from. Get a random, sorry, it's going to be ran. So random item from the array, and then we actually want to drag in the paper sprite component, and we want to set the sprite, and then on event begin play we're going to set the sprite, and this is going to be the random sprite that we generate. So we can test this by, let's just remove the source sprite, and let's clear that. So that's effectively blank. So if we look at it now, there's not actually a sprite there, but when we spawn it into the world or drag it into the world, it's going to pick one at random. So let's test that. So let's just drag that straight into the world, and if we hit play, you can see that although it's tiny, that a letter has generated. So that being said, because it's so small, let's change this to, before we change the scale, let's close this padlock here so it's uniform. So let's do 5, let's hit play, and we can see now that the letter H is generated. If we close that and restart it, it's now X, and obviously again now would be K. So we can see that a random letter is generating every time, and with that then we just need to get a way of getting them to spawn sort of regular intervals, have it recorded, and then see if we've pressed that key to sort of remove it. Okay, so for the next bit, what we need to make is like a letter spawner or a manager of some sort. Now, what we can do is create a blueprint class. We'll pick an actor again, and then we'll call it letter spawner. Now we'll open that up, and essentially what we can do is we can get rid of the event begin overlap and the event tick, because we're not going to need either of those. And because this is going to be a spawner, this is going to spawn a letter every so often. There's going to be some sort of time period of this action looping. So what we can do is we can use a timer by event. Now what this does is every sort of time frame, it will sort of call this event. Now that'll only happen if we say that it's looping. So we'll say let's loop every 1 second, just to start with for sort of debugging. And the event we want to call is going to be a custom event, and let's call this one spawn letter. So what we're saying here is when we start this timer and get it to loop every second, and then what we want it to do is spawn actor from class, and the class that we want is going to be letter gen. So this is going to be the randomly generated letter, and of course obviously every time this gets created it picks a new random sprite, and then what we want to do is this needs a transform, or it needs a location. Where can I spawn this letter? Where can I spawn it? Where's safe? Now accidentally there I've just pressed compile because it's just a knee-jerk reaction for me. I always hit compile. But essentially what I'm going to do is I'm just going to save, and I'm just going to drag the spawner into the game. Now what I want to do is I want to get the location to 0 and 0. Now my Z location, I'm obviously going to have this above the screen, so then when they spawn they drop down. But before I do that, where's my letter spawner gone? Let's bring it back down. I just want to find out the boundaries of where I can spawn within, essentially. So if I move it all the way to the left, I can see that before it goes out, it's minus 1,500. Now, just to play it safe, let's pull that back 100. So that's minus 1,400, and if I have this right, it should be 1,400 on the other side. So that's kind of like my range limit. On the X, I want at least minus 1,400 to 1,400. So what I'm going to do is I'm just going to pop this, maybe not out of the screen, but at 2,500 there, just so I can see it. And I'm going to go back into my letter spawner now. And this transform, instead of giving it a transform, if we right click, we can split this into its bits. So we can see the spawn transform scale is going to be 111. The rotation is going to be 000, which they're both fine. We don't need to adjust the scale. We don't need to change the rotation, but we do need a location. So if we right click on this location, we can split this as well. And now we get given the X, Y, and the Z. So this letter spawner itself is in the world. So what we can do is we can get the actor location, which will get this spawner's location. Now if we right click on this return value here and split this, we don't need the X because that's what's going to be the random value. But we do need the height. And the transform for the, the location for the Y is going to be 0. You don't need to hook it up, but you could. So I'm not going to. But the X, we're going to want a random float, but make sure you select the in range one. So what we're saying here is, let's connect this to the X. What we're saying here is, get a random number between minus 1,400 and 1,400. So then hopefully that should be within the bounds of the screen. So what we can do is put these two together like that and make it look a bit prettier. So if I hit compile now, this transform should stop complaining. And in theory, this should work. Now, one thing I just want to check to make sure, obviously this paper sprite isn't going to be affected by gravity just yet. So over on the right under physics, we should be able to tick simulate physics, which we can't. Now I'm thinking this may need to be populated. So I'm just going to select the letter A. Yeah, so that for some reason that disables it. So even though we're going to set the sprite after the fact, it needs a sprite to be selected for the physics to be able to be enabled. So with that being done now, let's tick simulate physics, and hopefully if we have a look at the collision, it's going to block everything. If everything so far has gone right, when we press play, every second we should get a letter falling from the top of the screen. So there we go, we've got a Q, we've got a B, we've got a Q, we've got a J, we've got an N. That's working as expected, so that's perfect. So technically now we've got a letter spawner, like a letter generator, and then the letter spawner. So that's absolutely fine. The only thing we need to do now is every time we spawn a letter, we need to make a record of that letter, and we need to find out what key it should be associated with. So if it spawns a letter A, we will associate that to the letter A on the keyboard. So where should we handle that? Now, every time we spawn a letter, we get a return value. Now, the return value is that letter in the world. So what we can do to keep a track of that is we can create a new variable, and this will be, let's say, spawned sprites or letters, either way. And instead of it being a bool, it's going to be a paper sprite. So it's going to be a paper sprite, not a paper sprite actor. And then it's going to be an object reference. Now, if you right click, you can change this to an array, because we're going to have multiple, well, there is a chance that multiple of these letters are going to be on the screen at one time. So what we can do now is we can drag this spawn sprites in, and we can say add unique, and the unique one's going to be my bad, I am very sorry. So it's going to be a type letter gen. Let's change the type. Let's close that, get rid of that, let's drag that back in, let's plug that in, and then this should now match up. So every time we spawn a letter, we're going to be adding that letter to our array. And then we need to find out what letter that's going to be associated with. Now this is probably going to be done within here. So every time it picks a letter, we should find out what that letter is and what key would be associated to it. Okay, so to continue on, to get the correct key for which sprite has been picked, we need to actually get an association of, from the available sprites, if a random sprite was picked, let's say the B key, we'd expect this to be number 1 in the array, which then we can link each of these numbers to the corresponding keys on the keyboard. Now, I have to go back a little bit, unfortunately, because this random function doesn't work as I anticipated. What I would have expected was when it picks a random sprite, it will spit out the corresponding position within the array, for that number. So for example, if it did pick A as the sprite, I expected 0 to be outputted as the index value, which it turns out that's not the case. It turns out that this is actually a random number, which would then correspond to a random letter. So in actual fact, the output sprite and the index are two completely different things. Now, reading the documentation, it didn't appear to be like that, but in actual fact, it seems to be. So, for example, if I was to pick a random sprite, and instead of using this integer, I just print it to... I can't do that. If I was to instead print string, I just want to give you an example of what I'm talking about here. And if I just plug that in, so essentially this print string, although it looks ugly here, is going to tell me the number that it picked as we pick a sprite. So if I compile and play and then pause, let's see if I caught that. So this has produced the letter U, and unfortunately I've paused it before the print string has actually happened. So let's try that again. Okay, so the print string disappears. So this has the letter H, and it gave me the number 4. So if we then go back to the available sprites and look at the number 4, this is actually the E key. So this random int value is different to the sprite that it picked. So unfortunately, we can't use this random node anymore. Now, that being said, what we can do instead is if we was to get a random integer in range, which I guess we could use a float, but an integer is probably better. Let's get a random integer in range. Now we know our minimum is going to be 0 and our maximum is going to be 25 to make up the 26 letters of the alphabet. So if we use this random number, and then instead we promote this to a variable as random int, and then what we do is we get a copy. So what we're doing here is we're going to take this random number, which we know is going to be picking one of these items. So 13 it'd be N, 12 it'd be M. We know it's going to do this correctly this time, and we know we're going to get the right number for the right sprite. So we can just plug that into there, and on the face of it, this should function exactly the same. So it's picking random letters, except this time the integer number is actually going to match. So if we put in a print string again, and this wasn't intentional for this video, but this is a good way of explaining how to bug fix. So we've got the random int. Let's plug that into there. And let's just see what the first letter comes out as. So the first letter is 0 and it's A. And then X is 23. So that happens quite quickly, I do appreciate that. But the X was 23. If we scroll down to X, we can see that it actually matches 23. It was good that the first letter was A and it was 0. So we now know that this system's going to work. So let's delete the print string and let's continue on with the finding which key that corresponds to. So what we need to do is we need to get input from the keyboard, and we need to assign like the A key to number 0, the B key to number 1, the C key to number 3, and so on and so forth. So what we can do is, let me think about this for a second. We could actually use a select node to set the key. So what I'm going to do to start with, which will help us out, is if we make a new variable called required key, and instead of a boolean we set this to a key option, and then if we drag this out and set it, so this is when we set this is going to be the key that we need to press for this sprite. Now to get this, what we can do is if we use a select, now it's just a plain select, it's a yellow icon. There are a couple other selects, select by int, select by bool, they're not the right option. And essentially what we're doing is we're going to take in this random int as our index. So essentially this number is going to associate with one of these options. So if it's 0, it's going to pick option 0. If it's 1, it's going to pick option 1. Now this is where it becomes a little bit annoying. You're going to need to make 26 of these options, and unfortunately you're going to need to populate all of these with the corresponding keys. Now at the moment these options are just blank because it wants to know what the return value is going to be, and what you'll see is when you do that, it'll automatically now turn into all the key options. So we can go through this now. I'll skip this, so this will be done in a split second for me, but unfortunately you're going to have to go through and change all these to A and then B. So this isn't going to be a fun task, but I'll see you in just a minute where this will be complete. Okay, so we're just doing the last one here. So as we can see, that was a little bit tedious. So we've got the option 0 as A and the very last option as the Z key. Now our random integer will pick a number, and actually I've just noticed I put 26 there, and that should actually be 25. Because we're including 0, that should be 25. My bad. So we pick this random number, and then that's going to correspond to one of these options. So we know whichever sprite that it picks, we're going to get the corresponding key that it requires. So that's absolutely fine. Now if you don't want this absolutely massive select node here, what you can actually do is if you select them both, the int and the select, you can actually collapse these nodes, and it'll collapse it into this graph. Now if you double click, you'll get this. Yeah, there is no input, but there's an output. And if you'd like to, so that will actually come under your event graphs. So we can call this find key, something like that. Yep, and that just saves you having this massive node on your screen. So now what we can actually do is, if we go to our letter spawner, every time we generate a letter, its return value is going to have that key required in it. So now we can get which key is required. So every time we generate a letter, we're adding it to this array, and later on what we can do is we can receive a key press, and we can say, right, every time a key is pressed, check all the sprites that have been generated, and if one of them requires this key, then you've won a point. Delete the sprite off the screen, that one's done for, and we can move on to the next letter then. So let's action that. And what we actually need to do that is a player controller. So in the 2D side scroller, unfortunately within the blueprints, a player controller is not included. The one that's used in the game is just a default one, which unfortunately we can't edit. But they're very simple to make, so we'll just right click and create a new blueprint class, and we'll select player controller, and just for consistency we'll put 2D player controller, and let's open that up. And we don't need to make many changes to this at all. So we just go straight to the event graph, and the only thing that we really need to do is receive keys and then tell other blueprints that we've received a key input. So what we can do is there's actually an any key input action. So when pressed, we'll tell you what key has been pressed. And to get this key information sent out to all the other blueprints, we can use something called an event dispatcher. So if you click on add event dispatcher, and we're just going to call this pressed key, and then what we'll do, we'll drag this out and we're going to call this event dispatcher. So we're going to call it and we're going to send everybody a notification saying a key has been pressed. Now the only thing we need to do is, if you see this this messenger doesn't really send the key in the message, it just kind of sends a notification which is sort of dictated by this envelope. If you select the event dispatcher in the left hand column though, under default values and inputs, we can add an input, and we can just call this key, and instead of a boolean we'll have a key type, and I'll hit compile, and then you'll see here that the key can just be connected to that, and then when we press we can activate it. So we press any key, we're going to call this event dispatcher, and we're going to send the key that was pressed with the message. So that's pretty much it for the 2D player controller. Now one thing I will just want to mention is up here at the top where it says blueprints, we are going to want to change the game mode to use that player controller, otherwise that's never going to happen. So under blueprints you can go to world override, game mode, go down to the very bottom and you'll see player controller is just set to a generic player controller H. But instead, if we go to the select, you should see now that your 2D player controller is available. Select that, and then now when we press a key, that event dispatcher is going to be called. So with that being said, what we can do is we need to get access to that event dispatcher, and we need to bind an action to that key being pressed, and that action is going to be us checking to see if one of our sprites requires that key to be pressed. So we can do that, and because the player controller is stored within the game mode and is quite an important property, you can actually just type in get player controller and you'll be given this reference to it. And then from that, what we can do is we can cast to the 2D player controller. Now this cast requires an execute input to sort of power it up, let's say. But because I'm pretty certain that this is never going to fail because we've set it in the game mode that this is the controller, you can actually convert this to a pure cast. Now just be aware that the execute one can fail and will have an output for the failure, so it's almost like it prevents your game from crashing because you're going to handle that failure correctly. Now with a pure cast you don't have a failure, so if this was to fail it could break your game, it could make something not work. But again, with us setting in the game mode our controller, I'm pretty certain that that's not going to happen. So anyway, as the 2D player controller, we now have an event called pressed key, and you can see here that we can assign something to it, call it, we can unbind it. However, we want to bind an event of our own to that action. So this is basically saying whenever I receive a notification of a key being pressed, or I receive the message, I want to use this. I want to run this event. So before we do that, let's just connect these up. And the event that we want to run is going to be a custom event, and it's going to be check key. I'm pretty good at capitalizing that E in key. Now, what you can see is that event has naturally been given that key input, which we've closed it, which we've sent via this dispatcher. So now we've got a key, we've got our spawn sprites, which have keys required, and now we just need to do a comparison of the two and get them to work. So what we can do is every time we call this event, now I know this is just like in line with this, but this every time that a message is sent over, we will get a response from this. That might not have made any sense, but what I'm saying is every time a key is pressed, this will call. It's not just going to be a single action. It will always be callable. Anyway, so what we should do with the check key, we should do a for each loop. Now I'm going to use a break. What this is going to do is if we grab our spawned sprites now and plug that into our array, what we're going to be doing is for every item within inside this spawn sprites. So let's say we've only just spawned one letter, letter A. For that one letter, it's going to go through. We're going to do a check, and then after that, it's going to be finished. So let me just delete that just in case it messes anything up. So for each item in here, let's check to see if this item's key required is equal to the key that we pressed to start it off. Let's just pull that down like that. Yep. So is this item's key required equal to the key we've pressed? If that happens to be true in our branch, so we connect that to our loop body. If that happens to be true, what you can do is add a point to the player's score, and then we need to remove that sprite from the array, and then we can destroy the letter, or we can remove the letter from the game. So if that happens to be true, let's get our spawn sprites, and we want to say remove item. So I'm going to move this up here, so then we've got room for a failure, and we need to take this array item and plug that into our remove, because essentially, let's see if we can make this neater. Essentially, as we're looping through, we're going to stop at each one and check. Once it's true, it's this item that we need to remove and nothing else. And then afterwards, oh, I didn't mean to do that, sorry. Afterwards, we need to grab that and destroy this actor. So we're going to remove it from the sprites and then destroy it, if they match. If they don't match, you can write a message like wrong key. Or you can play sort of like a denial sound like or something like that. That's probably a better thing to do. And the same with the true. If once you get it true, you can have like a ding. You've done it right. Now, I used a break one. Now, if this is true, I don't want to continue looping through my array. I don't want to continue looping through my array to go through every other letter if I've succeeded or it's been successful at the very first run. Because if I've got, let's say I'm really bad at the game and I've got 10 items on the screen, if I get the first letter in this array, I don't want the array to keep checking all the other ones because it's going to waste sort of performance. So what we can do is somehow we need to get this true to break this loop. So what we can use is a sequence. So if we try and get this to look a bit prettier. So what I'm going to do is I'm going to change this then 0 on this remove to then 1. And then the then 0 is going to be our break. Now, if you double click on a line, you'll add a reroute node and we can make this look a lot better than it currently is. And what I'm going to try and do is make enough space to fit this in. Like there, like that. Okay, I didn't need to do that because I had node there, but yeah. So what's happening is we have a sprite. When the key's pressed, we check all the sprites for the key required versus the key pressed. When one of them's true, when one of them matches, we're going to end the cycle, but after the cycle's ended, we're going to remove the sprite which was correct from our array, and then we're going to destroy it. So in theory, now, if I press play, I should be able to play my game. D0. Okay, that is unusual. So what error have we got here? So we've got accessing none, trying to read the call function letter spawn, destroy actor. Okay, so just did a little bit of testing. Now, what I've actually figured out is the removal of the sprite seems to be causing the destroy actor some sort of problems. So if we actually remove the sprite and then connect up the destroy actor, what happens is we do get a playable game. So if we press the right key, we do get the letters disappearing as we'd expect. Now the only downside is what you'll see here is because we never actually removed the sprites from the array, every time the next letter's spawned and we press a key, it's technically still trying to compare that key to all of the, let's say, dead letters, because they still reside within the array, but they don't exist. So they're kind of like empty letters in a sense. So we need to find a different way of removing these from the array, which doesn't conflict with the destroy actor. So what I've thought about is, obviously, technically, we're in a 3D world. So technically, we are in a 3D world. What I'm thinking is, if I put a box collision to sort of cover the area of the game, and when a letter leaves that box, then we should remove it from the array. So if we destroy it, it's technically left. So then another routine should run that, right, now it's left, we should remove it from the sprite. So let's just give that a try. I feel like this will work, so I'm confident just to push on with it. Yeah, so under the letter spawner, I'm just going to add a new component and put box collision. And I guess I'm going to need to get some dimensions of how big the area is. So from the letter spawner, if you remember, we got this size of 1400 by 1400. We know that the letters are going to stay within that. So if I set my box width to be, I guess that'd be 2800. Now I don't know if that's right or wrong, so I'm just going to go back here. Okay, so that was completely wrong, obviously. Where have I set that? So let's go back and change that to 1400. And that's about right, but I'm going to make it a little bit bigger just because I'm nervous. So 1500, that fits nicely across there. And then for the height, let me just right click on this camera and pilot it. And what I'm going to try and do is, with the letter spawner selected here, I'm going to scroll down in this. Sometimes it's very collapsed up like that, but you can actually get into the components. I'm going to select the box and I can see the size here. So it's actually going to be the Z value. And what I'm thinking is, I'm just going to type in 1000 to start with. And that doesn't look too bad, because by the time it gets to here, you've kind of lost anyway, haven't you? So if it falls out of the bottom of there, that's probably good. The other thing that's making me nervous is how high does that go? I guess that's fine. I guess that's fine. But actually, I'm just thinking this letter spawn is actually going to be a bit higher up, isn't it? So at the moment, my letters are spawning here. Whereas realistically, I'm going to have my letter spawner off the screen. What's this other dot here? Oh, so in fact, I've actually just moved the box instead of the actual letter spawner. So let's move the letter spawner. That's going to be, what was it, like 2,800 to not be visible? So it's going to be like that. And then we can move the box separately. Let's pull that down. So where it's just going off the screen there, it's probably fine for me. So let's just press play and let's just see what happened. Oh, actually, no, let's not press play just yet. Let's go back into our letter spawner. Now, because we've got a box collision, the box collision handles its own collisions nicely. So with it selected on the right hand side, you can see here that you've got like a on component end overlap. Let's tick that. And just for sort of like debugging, let's just type a print string and let's just say letter left, something like that. Just anything that we're gonna know is working. So a letter comes in, letter left, letter left, letter left, letter left. Brilliant. So that letter is going to be an actor. So what we can say is our spawned sprites, let's get them. Let's remove an item every time something ends the overlap. And the item we want to remove is going to be a sprite. So in theory, I'm thinking that should allow me to connect to that. So maybe we need to cast to letter gen. So in theory, technically what this is going to do is only if a letter ends, leaves the box will this do. And then that should connect into there. So that's right. So we're going to cast to a letter if it is one. If it's not, it'll fail. So that'll be a saving grace if anything else hits it. Let's hit compile. And if I don't press anything and exit, I don't have any error messages, so that's good. But now if I play the game, G, Y, H, and leave, I also don't get any error messages. So that means that we're on a winner there. So now what we've got is a system of, we're collecting letters, we're checking what key we've pressed, we're comparing that to our database of letters, and if we hit the right key, we're then destroying the actor, and then because that's left the game area, which is our box, we're now removing them from the array. So at this point, what we could do is add in a point system. Now, I'm not too sure of the length of this video, so I might do the point system as a part 2. So I've decided to do the point system as a part 2. Apologies if you've got this far and you want to continue. The point system's not going to be that long. However, the length of this video already has exceeded what I expected. So I know this has been completely different to what this channel normally has, and it's always normally a first person or a third person sort of project. But if this was of interest to you, or if it was useful, or if you've learned something, please consider giving me a like. Also, if you've got any feedback, or if you wanted to just mention anything, please put a comment down below. I tend to always respond to all my messages. So yeah, I like getting that feedback. It's nice to know that what I do is appreciated. If you do appreciate what I do and you want to watch more, please consider subscribing. That helps me out also. I'm on track to get to 1,000 subscribers. So if you do watch the videos regularly, or if you've come across my videos quite a lot, please consider subscribing. It does help me out a lot. If you want to have a chat with me or anything like that, there's a Discord link down below. We have a server. There's a few of us in there, and we can chat. I can help you with projects or what have you or whatnot. If you want to support me, there's also a Patreon link down below, and this project will be packaged up in its current state and uploaded to Patreon. That will be accessible for all member categories. So my cheapest one's like £1, which is like, I think 70 cents or something like that. But yeah, everything's appreciated. Thank you for watching, and I'll see you in next week's video.